So we're going back to talk about some basic integration rules because we're going to do some more things with integration. So just remember, we've covered a whole bunch. They're in the table here that I gave you. I am not going to go through them. You should know them. If you have questions, you can ask in class. Just remember that an integral is an antiderivative. So they are just really opposites of each other. Just make sure you look at all the rules. What I want to talk about is different techniques that we can use for basic integration rules. So there's a lot of things we've done. You know about U substitution. You know about the rules that you can add all the integrals together. But there's some other things that you've probably used that I'm just going to list out to make sure that we have them all there. So the first one is sometimes you have to expand the numerator. And we've been doing that in class with some of the things that we've done. So an example would be if I had x plus 3 squared, if I want to integrate it, I would just expand to x squared plus 6x plus 9. Next one is maybe sometimes I want to separate the numerator. So if I have 1 plus x over x squared plus 3, I can separate it into 1 over x squared plus 3 plus x over x squared plus 3. And maybe I can use some of the other rules like use substitution on this one to be able to integrate it, and maybe some trig rules as well. The third one is I might want to complete the square. We might want to use this also when we're doing inverse trig. So if I had something like 1 over the square root of 2x minus x squared, I can rewrite that. I would complete the square, so I have x squared minus 2x. I have a negative on the outside. I would add half of that square root, which is 1. This becomes a negative x minus 1 squared, but I have to subtract 1 as well. So I have, it's a square root in here, but it would be 1 minus x minus 1 squared. Also, I might, if I have improper rational fraction, I want to divide it. And I usually do this if they're the same degree. So an example would be if I had x squared over x squared plus 1, I would divide x squared plus 1 into x squared, and I would get so plus 0x plus 0, and it'd be 1, and if I subtract this x squared plus 1, I would get minus 1, so this would be the same as 1 minus 1 over x squared plus 1, and maybe I could do something with that. Inverse trig comes up a lot here. Okay, I may want to add and subtract the same term. In the numerator. And let's say I had 2x over x squared plus 2x plus 1. I see that if I added something here, maybe I could use substitution. Well, the derivative of 2x is 2, so what if I have 2x plus 2 minus 2 over x squared plus 2x plus 1? And then I can rewrite it as 2x plus 2 over x squared plus 2x plus 1 minus 2, and we know that that is the same as x plus 1 squared, and I could probably use substitution for both of them in this case. I could use trigonometric identities. Such as something like I know that cotangent squared x is cosecant squared x minus 1. I might want to put something in for another so I could do something with it. And finally, the last one is multiply or divide by a Pythagorean conjugate. So if I had, an example would be if I had 1 over 1 plus sine x, if I multiply this by 1 minus sine x over 1 minus sine x, I get 1 minus sine x over 1 minus sine squared x, which is 1 minus sine x over cosine squared x. And I can rewrite this as 1 over cosine squared x, which is secant squared x, minus sine x over cosine squared x. We know this, integrate this, and this we can use substitution. So we're going to do some examples, but those are some of the techniques that you might want to use.